Okay, and really quickly we're going to talk about an or statement. Or statements will know because it'll always have the word or in it. With an or statement, if either thing is true, it makes the whole thing true. So or statements, you saw a quick example on the number line. Here's what they look like. We want to graph all of the numbers that are either less than or equal to -1 or greater than 5. Well, all the numbers less than or equal to -1 would go all of those numbers. All of the numbers that are greater than 5 would go that way. This is what an or statement generally looks like, something like that, two arrows going opposite each other. It's a general rule. It's not an always and for sure always rule, but for our purposes, we'll keep it that way. So that means that any number that is down here or that is up here is part of the solution set to this thing. So if I pick a number like -3, -3 is less than or equal to -1. It's not also greater than 5, but that's okay. It doesn't have to be. Or if I pick the number 8, 8 is greater than 5. Again, it's not also this, but it doesn't have to be. It's one or the other makes it true. The numbers that are not covered on the number line, like the numbers in between here, like the number 2, 2 is not less than or equal to -1. And it's also not greater than 5, so it's not part of the solution set. So our final answer would be from -1 on down should be shaded. Also from 5 on up is shaded, but not that area in between. So the solution set is anything that's covered on the number line. So in Delta Math, you might see something like this. It literally says the word or. We know this is going to be an or. We want to graph all of the numbers that are less than -9 or greater than -5. So on the number line, I find that -9. I click and I drag. I find the -5. I click and I drag. And again, I want to make sure I have the open circles because these are both less thans. So an or statement, and again, my iPad's doing weird things here. Or statements look like that. If I'm shown an or statement, if I'm shown something where I have those two ends of the number lines here and then I'm being asked to express the interval, notice in the choices that they've given us, we have the word or here. Or is one of our choices. So what I would do if I'm typing in that answer is I would say x is, let's see, I need it's an open circle, so I would say x is less than -3. Then I'd hit that word or. X is greater than 5. And I submit my answer. And again, I pay attention to the open circle, the closed circle. But that's considered an or statement. So we have ands and ors, and statements and or statements, these compound inequalities. And this is what I call my general rule of thumb. So general rule of thumb looks like this. Here's why I call it a rule of thumb, right? I usually, if I'm in front of you, showing you this with my thumbs. And statements generally connect. So they start with two endpoints, and they connect together like that. Or statements don't connect. They generally go in opposite directions. So I would show you that with my thumbs. Again, if we were together, my rule of thumb. Ands connects, ors go different directions. And that's it. And statements, or statements, a really short, quick introduction today.